Hello everyone, welcome to our second talk for today, solving problems with inelastic collisions. This is actually part of chapter 3, section 6 in our textbook. Again, let's get going. So just like last one, we're basically using math models to solve inelastic collision momentum problems. Keeping in mind that momentum is always conserved, we're going to use our mathematical computations. We're going to look at pattern, scale, proportion, and quantity with the use of our calculator. So, inelastic collision. Basically, the idea is you have two objects that collide and stick together. Two objects collide and stick together. Basically, you start with two objects and you end with one. So you can see down here in the picture, we got one blue ball, one green one, and then afterwards, go splat, and they stick together as one. And so you typically will have momentum of two objects in the beginning because they're two separate objects, and you only have momentum of one object when you're done. And so when you break that down, M1V1 plus M2V2 initial equals M final, V final, where they're both stuck together. All right, so some examples are catching a ball, bullet goes into a block, and of course we'll look at our first example together. So example 1, two trains, sorry I'm missing an S there, collide and couple, meaning they stick together. As shown in the diagram, determine the final velocity of the coupled trains. So here we have a 1,000 kilogram train going 10 meters per second, colliding with a 1,500 kilogram train that's at rest at the time. When they couple, that means they stick together, and then our job is to figure out what is the final velocity after it's all said and done. Okay, so to solve this one, again, because we're asked for the final velocity, we really want to use the bottom equation in this case. If I were asking for momentums, then of course you just leave it like this, but because we're looking for final velocity and you'd be able to solve it, I'm going to use that one right there. And so initially I've got a 1,000 kilogram train going at 10 meters per second plus a 1,500 kilogram train going at 0 meters per second because it's at rest. You see that right there. And then that should equal, now these two combined, if this one was 1,000 and that one's 1,500, then these two combined should be the sum of both of those, which is going to be 2,500 times V final. All right, so then to solve this, it becomes 10,000, when I multiply that, plus 0 is just 0, equals 2,500 times V final. And again, to solve, I just divide both sides by 2,500, and V final will equal 4 meters per second. So that's the end of it. If you have any questions, again, please stop by our office hours if you have any questions. All right, you guys have a great day.